All right, we're going to start on chapter 2.6, and we're going to bridge it from 2.5, our algebraic proofs. And I'm going to try and keep it under 5 minutes, but no promises. We start off with the concept that we're going to have an if statement right here. Here's our if, and there's our then right here. But to get there, we have to use things called definitions, postulates, properties, and theorems. Theorems are just basically statements that are proven to be true. So don't let that word get you all worked up. It's just something that we're going to take for true in this course. As you saw in the algebra ones, we say if x plus 5 is equal to 7, then over here would be x is equal to 2. And we have to use these definitions and so on to prove that it's the case. We do it step by step. Same thing in geometry, but in geometry we deal with shapes and stuff like that. So when we're dealing with shapes, we're dealing with properties of congruence. Previously in algebra we did properties of equality because we have equal signs. But look what's different right here. We have a congruent sign right here. It's the equal sign with the little wavy thing above that. My 7th period didn't get to see this on Friday. And we deal with figures. If figure A is congruent to figure A, so on. Okay? And we have the reflexive, symmetric, and transitive, just like it is in equality, but now we're dealing with congruence, and we'll initial those POC. Big difference. Don't mess up with your POC versus POEs, property of equality versus property of congruence. Know the difference of those. This deals in shapes because of this little congruent symbol. The other one deals with values, numbers, because of the equality symbol. Here's a couple of theorems. First one, and let's get used to reading this with an if-then statement. If two angles form a linear pair, then they are supplementary. Very often we're going to want you to write this as your reasoning rather than just say linear pair theorem. And here's the hypothesis. Here's your if, and this is your then. If A and B form a linear pair, then angle A and angle B are supplementary. There you go. And congruent supplements theorem. Here's our if-then statement right here. If two angles are supplementary to the same angle, then two angles are congruent. Here's our hypothesis. These are supplementary, then these two are congruent. Let's get into an example here. Well, actually, I want to do this first. This is what we gave you. When we're writing justifications, and this is a big deal, because this is what you're going to be facing with on your first assessment here coming up. You're going to have to write justifications for maybe one instance. We, on Friday, came up with the properties, and we had to write the if-then, finish the if-then statement. What we're going to do now is we're going to give you the if-then statement, and you're going to tell me what the properties are. Just like that. We'll give you this, and this will be all blank right here, and you got to tell us which one applies. So let's take a look at this. Here's an example. Write a justification for each step given that A and B are supplementary and the measure of angle A is 45. Well, just not too long ago I would give you this and you just subtract, well, supplementary, 180 minus 45, there's my answer. And you knock it out pretty quick. But we have to justify every little thing. So we're going to start off with angle A and angle B are supplementary. Measure of angle A is 45. Well, guess what? That was given. This was all given right here. So what do you think this is? You're right. It is given. And I'm just going to toss these off to the side because it saves me the trouble writing. And look what we do here now. Measure of angle A plus measure of angle B is 180. That's probably a definition somewhere. And we derive that by given that A and B are supplementary. Look at this. That came from our definition there. So here we go. Definition of supplementary angles. Look what we did here. We took angle A and turned it into 45. What property would that be? Well, we just basically substituted, didn't we? And it's the substitution property of equality. And it is equality because we're dealing with equal signs. And then we have measure of angle B is 135. Think of what we did. We got rid of that 45 right here. We subtracted on both sides. So there you go. You have the subtraction property of equality. Very standard, very basic proof. We start off with geometry. We get into some of the equality properties. Let's go ahead and take a look at some more examples. These are standalone examples. And we have to read these carefully. And again, We're going to do a lot of this in class on Monday. We have several of these to go through. So this is just kind of like an intro. Given measure angle 1 and angle 2 are 180, well, that tells us something. And measure of angle 1 is equal to angle 3. That's important given information. Then here's my conclusion. Here's my if. Here's my then. I got to prove this. Measure of angle 3 plus measure of angle 2 is 180. Well, what reason did we do that? Well, think about what we did. This right here tells us that if these are equal, we can substitute measure of angle 3 in for angle 1. And that's exactly what we did. We did the substitution property of equality. This requires a lot of thinking. This is why geometry is such a beautiful course. It makes us think so differently at times. Let's take a look at the next example. Angle 4 is congruent. Well, I want your eyeball on this right here. So what property are we going to use? Are we going to use properties of equality or properties of congruence? Hopefully that was self-answered. 4 is 5, and then 5 is congruent to 6. Then 4 is congruent to 6. Yes, that's right. It is the transitive property. So let's go ahead and zip this out. And it is the transitive property of congruence right here. Don't get these things confused. That will be a no-no. I will get irritated. A couple more examples. These are the last ones. So I should be able to keep it under 8 minutes. Measure of angle 8 is 90. Measure of angle 9 is 90. And the reason, we give you the reason, is substitution property. So what exactly did we do? Well, we substituted. If this is 90 and that is 90, then guess what? These two are congruent. So we have measure of angle 8. Equal is equal to the measure of angle 9. Notice that we used measure, therefore we're using the equal sign. Here we go again. Angle P is congruent. So yes, we're using congruent as transitive property. To measure of angle Q, and Q is measure of R. So almost like syllogism, we go right there. Then we can conclude measure of angle P is congruent. Not measure, I'm talking wrong, to angle R. All right, I'm going to end with these two examples, and I'm going to look at possibly uploading a proof, and we slowly integrate our proofs over the course of the year. So we're not going to be throwing hardcore 100% long, lengthy, multi-step proofs at you this week. We're going to gently push those in, especially when we get the triangles. And triangle proofs, yeah, we're going to have to get pretty good at it by then, but we got a few weeks before we hit that. Alrighty, I'll see you tomorrow.